build plate for the MakerBot. It's pretty neat how you can just kind of detach it.
Ooh.
So it makes it easy to bring out to a different surface and basically clean out once the print is finished. So let's kind of review that process over here. As you can see, there's already a failed print here that we're going to remove. We use spatulas. There's different kinds you can use, and it's a little bit of wiggling that's involved here. So if the plastic one doesn't give, then you want to use the metallic one and kind of nudge it up a bit, and then once you get one corner up, it's easy to get the rest of it off. Yeah. There's always little artifacts that are left, so just make sure those are clean. And this is an important step to do before the next person can print. You want to always clean off your plate and get it ready. So now let's remove the filament and replace it with a different roll. Up here, if it's on, you can see that one of the options is filament. So I select that and press the wheel. And since there is already material in there and it's pretty much stuck inside, I click unload filament. It's going to hit the target temperature of 215 Celsius. Right now it's rising to that point. And once it gets there, I'll be able to remove it and unspool it and retract it. There's a motor inside that's going to handle that for us, so don't worry about that. The material we're using is PLA, which is a non-toxic polymer that basically all of the machines here should be using. But PLA is pretty standard. It's one of the cheaper ones. It's for classrooms. So stick with that one. Okay, it looks like it's getting ready to hit the target. It'll soon start retracting on its own. And there we go. Just like that. It just spits it out. It's hot enough to remove. Very easily comes out. The next stage is to actually change the spool. So back here is where it lives. Just take this thing down and hold it all the way until it clicks in place, because if you don't, it might fall down and it just makes a lot of noise and it could break it. Now you can basically spool it back like this and remove it. And maybe a different color. Where do we have colors? Okay, so once you get your thing ready and ready to spool, you're just gonna feed it through here. So it comes out through this tube. And okay, that's what you want, a little tail that you can insert over here. Okay, just like that. Now it's not really spooled in there. We got to go back to filament and click load. And again, it goes through the same song and dance, heats up until the point, and then it will start spooling it through. At the end of the target, you'll start seeing material ooze out of there. That's when you know the filament has been successfully inserted and spooled. Use MakerBot Cloud Print to manage our 3D printers and send jobs to them and monitor the workspace. So we're going to sign in here, MakerBot. Okay, so this is the workspace. Here are all the printers that have been added to the workspace. There are some warnings here, so you'll see those if there are some issues. All the different printers are listed here and their current status. So you see an image. This one appears to be offline. Some of them have had other issues like out of material or filament slips. And you can also see the ones that are finished. Right now, all the build plates are clear, so there's nothing to actually see on them. But once a job is completed, you should basically approve it or say that it was successful. And then now it'll know that it's been cleared from the queue. This one could start its next job. So that could be done like that. And start print, and it'll begin warming up. and it'll do its thing. Yeah, so this is just a quick way to see what's happening throughout all the printers, and it also allows you to manage some of the members. So uh, who's going to have access to this dashboard. So you can add members by email. You can see previous jobs and a few other things. Okay, next, let's add a print job to one of these printers. That means we have to actually find the 3D model file to send to any of these, and which will then slice it up and put all the settings and basically get it ready to print. And then we can start the print job directly from this Cloud Print interface. So let's get a file to print. A popular place to get them is Thingiverse. I've already selected a pretty simple file. So when you find something in Thingiverse, you'll probably come to a screen like this, in which you have a number of files, maybe just one, or sometimes it could be a quite large number of them, depending on the complexity of the print job or the file. So in this case, we have an option of getting all of the models here, all the different bolts, or individual one by one. Let's just get all of them. So I'm going to download them. I've already downloaded them, so they are all here, all screw sample.stl. We will be basically uploading that to the Cloud Print. So let's go back to Cloud Print. For this, we're going to have to enter print preparation mode, which is up here in the top. Selecting that takes us to this screen, which is just one of the printers. And here in the top, you can see which printer you have selected or has been selected for you. And you can click that one and basically select a number of other printers, and it tells you their status. So if I want to pick number 12, I'll choose that one. It's typically good to always go first to this screen and find the printer that is actually ready to receive another print and doesn't have some error or isn't in the middle of a print. So this one, let's see, 11 seems to be idle. It does have a print job in the queue, but we can ignore that. So we could send it to that one. We could send it to this one by basically approving this print job. We can send it to number 7 as well, and then skip this one. But number 16 seems to be idle. There's no upcoming print jobs. I think it's the color black, which is fine. I will use that one. So in this interface, I'm going to select Replicator 16, and it'll just change the outline because that other one was a different size. And now all we have to do is import the file. So we have a file to select from their downloads folder, the STL. It imports it. Now this is the scale that it was saved at. So you have the option to actually increase the scale of this. But with certain pieces like screws and bolts, I'm a little reluctant to scale it since the threading has to match. And the designer of this model probably went to great lengths to make sure that that did work. So I'm not going to scale this. But if you were going to scale it, you could go to this section here, to this button that says scale, and you can increase it or decrease it by percentages. That decreased it, and all of them also followed suit because they are linked, uniform scale. I'm going to undo that with a Command Z, and then basically print as is. If for some reason you scale them and a model happens to be too large for the build plate, it will immediately turn it into yellow outlining. So it lets you know that it's outside of its prints area. And I'm going to move it over here. I can move it over here, and that would be corrected. It's a little bit slow. Yeah, but as I mentioned before, I'm not trying to scale this. I'm just going to undo all of that. And now we can print it. So over here on this panel, we have several things to take notice of. Right now we are using a balanced print, which is fine. The good thing about Cloud Print is that it does give you tooltips for all of these things, so you can quickly see what a particular setting might be adjusting. So A good balanced print or draft if you're trying to do a quick one to see if it's going to work, more for prototyping. And then this is for really, really fast, that don't have to be kind of durable, that they're just for temporary usage. Um, so here we have some important settings. So this is another way to change the quality. The layer height basically determines how fine each layer will be. So the smaller this number in millimeters, the more layers it's going to make, and each one will be thinner. So you can expect a cleaner, more neat print. However, it does increase the time because it's got to go around and around more times. You can also adjust the infill of a shape. In this case, these should be pretty solid. I don't want them to be hollow, so I could move it up and down, but I'm gonna just leave it as is. And then also the number of shells, and it tells you there having a thicker wall might be something you desire, or maybe it's not. And the more material you use, the more layers you have, the more density. Obviously, all of those things are going to increase the time for the print to be completed. Certain models will require support when there's an overhang, more than 45-degree angle on any part of the model. It's a good idea to add breakaway model material, and that basically provides a scaffolding for parts to be printed upon. Otherwise, you may have some print that just kind of dangles in the air, doesn't adhere to anything, and then you end up having a print that doesn't actually work. So having this is good for when you have an overhang. And however, in this case, I don't anticipate that with these shapes. If you zoom in here, you can see that there is really no overhang going on. And then the base layer. So the default is to use a raft, which is a layer that goes beneath the print. It's a good place for the thing to adhere to, and it's usually recommended. However, you can remove the raft if you are trying to save time as well. There are more settings here, but these are some of the basic ones. So let's just kind of reset everything here. Yeah, balanced. And let's just do the regular 0.2, which is a kind of a rough, but it'll still work. Okay, and then we select print. Slicing basically means that so a file needs to be prepared first, and then it gets sliced. And when you're slicing a file, it basically converts the 3D model information, which is basically dots and points in space, to instructions to the machine on how to move, how to extrude material, what temperature to set. So it's basically instructions for the actual 3D printer, translating what's the model shape and size and orientation and everything. But you don't have to worry about any of that. Basically, you just have to wait for it to slice. You can see there's a queue. You can also look at the print preview here. Here is a view of the print job step by step, layer by layer. So this is going to take about 160 layers to complete. And it starts with a very basic raft. There's also an estimated time for completion, so 45 minutes. How much material is estimated to be consumed, 9 grams of PLA from the spool we've inserted, if you keep track of that. Okay, so it's in the queue right now. So let's go to the workspace management, and it says, okay, it wants me to confirm that Replicator 16 is ready to go. So this is the last chance to see if there is something else still on the build plate. So I can confirm that it's clear. So I'm going to start the print. And Replicator 16 basically starts heating up, sends the data to the machine, and will begin printing.